I have coded these colourful, complex 3D shapes, and I will show you how you can do the same we're using Python Turtle. Let's get into it. Firstly, we set up the program. So we import the turtle, and we are going to use trigonometry values, and that means we will import math, and these trigonometrical values are actually I just got these values based on luck. So don't ask me where I got these from, because I got them from luck. And then dimension 3 equals turtle.Pen, and dimension 3 dot speed 0. I could say 3-dimension, but that won't work because you can't have variables that begin with a number. It has to begin with a letter. It can end with a number, but it has to begin with a letter, and you are allowed numbers between letters in variables. And iTurtle, just to save that extra bits of data, so that it can run just a little bit faster. Here I'm going to use object-oriented programming to create the shapes. So class, okay, maybe not. Class shape 3D. Define in it initialization self with, and we are going to initialize.length. That's it, and we don't need anything else. And now we are going to define a dodecahedron, and define dodecahedron self color 1. So I'm going to use 6 colors to fill the faces. D3.set heading 0, because so that we could configure for drawing the dodecahedron, and we are going to use pentacoordinates and decaCoors. Actually, no. And we are going to store the values of the pentagon coordinates in Decagon. So we are going to draw the dodecahedron by drawing a pentagon and a bigger decagon around them, and then we just connect the edges together so that we get a dodecahedron. It looks like a dodecahedron. Now, colors equals color 2, color 3, where we use a loop to fill in all the faces that these will be used, and then we actually start drawing the dodecahedron. So we do that first by drawing the decagon, and for I arrange 10, decaCoor.append self.length. No, actually we are going to record the coordinates, d3.xCoor, d.yCoor. So here is when where we record the coordinates, penta, and then here we actually, what's happening here? And here we actually draw the decagon, and then don't ask me where I got these sign values from, because as I said already, I just got them based on luck, and this is called trial and error. So that I have to try multiple times before I can get the exact value. And where you code these shapes, the variation of these shapes yourself, you might have to use trial and error to do it. Dot left 36 and d3 dot right 108. In fact, I'm going to remove this. d3 dot back self.length. So here I am trying to configure get the turtle ready to draw the central pentagon. Cosine 60 divided by 180 math.pi. I could just say divide by 2 instead of all of that. But I'm going to leave it like that. And then we have configured drawer for the pentagon, and then we actually draw the pentagon. Drawing. d3.fill color 1. d3.begin fill d3 for I in range 5. Here we begin to fill we set the color and we begin to fill the pentagon, the chord, and here we make a record of the coordinates of a pentagon and decagon, and we need the coordinates of the corners so that in later stages we could draw so we could fill in all of the other faces by drawing the face using these coordinates. Dodecahedron edges drawing. d3 dot right 26. d3 dot forward. So basically, what I'm drawing is the edges that connect the decagon, because when you look at it from the front, it looks like the outer borders will appear to look like a decagon. But 100 forward self.length math.cos 60 to 500 times pi. In fact, this is tedious. I'm just going to copy this command. And then we have successfully drawn an edge. Left 126. And then here we actually draw the central pentagon. Here we actually is there. Left 72. And here we have actually completed the. Oh, here we have actually finished drawing the outlines of the dodecahedron. So and the main program shape 3D dot dodecahedron shape 3D length size 100 dot dodecahedron dodecahedron red, blue, lime, pink, turquoise, green, and I failed to put math.pi, and there we go. We have a dodecahedron. Here we go. We have a dodecahedron, and I know only this face is filled with red at the moment, but now we are going to fill the other faces. So So now fill in the faces in color. For I range 5, d3.fill colors I plus I, so that for every time it runs through the loop, it just goes to the next item in the list of colors, which we have defined here, and then fill, and then we begin a set of commands that draw it. We'll go to enter coordinates I, d3.go to coordinate I plus 2. So basically this is going to the I plus 2, d3 dot go to decaCoor I plus 2, and then no, not I plus 2, I times 2 plus 1. So go to decaCoor I times 2 plus 2. Here we will get a list index out of range error unless we make a modulo, making it so that if this number is 10, then it goes back to 0. Go to pentacoordinate I plus 1, and then we modulo this by 5 to eliminate any list index out of range errors. D3 and fill, and I'll explain all these coordinates here. So as you can see, the border has here, the Pentagon bit has been overlapped a bit. It's been distorted. So where I say pentacoordinate in the first iteration, it goes here, and the it goes here, and then it goes here, then goes here, then goes here, and then goes here, and then it finishes filling like that. So like this, like this, like this, like this, like this. Those were the set of commands that I've used. This is because this is pentacoordinate I. This is the first one, second one, third one, fourth one, fifth one. This was the first one, second one, third one, fourth one, fifth one, sixth one, seventh one, eighth, ninth, 10th. This actually starts from 0. So 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and back to 0 here. So that's when the turtle successfully went over a border, and it stops here. Now this place it just fills it in, and if there's it doesn't matter if there's a gap in the between the lines. It just fills it, it just creates an imaginary straight line between the start point to the end point. I just fills a gap, and so on and so on and so on until we get this Dodecahedron. Now we need to reinforce the borders, and I could do it in, for example, I could do it just by making a loop and then asking it to go forward and then turn left and then go forward and so on. But I'm just going to cheat a bit by saying d3.go to enter coordinate I minus 4. So that it reinforces a border, and it reinforces a border by using the Pentagon coordinates. And I say this because it will help with configuration in later stages. And I found that out by trial and error. Now we have finished coding the dodecahedron. Now, octahedron. We need to code the octahedron. Color 1, color 2, color 3, 4. And X, Y, D4, D3, Icosahedron. So that we get the original position where it started off. Original location where it began. Self.length. No, don't need to call that because that's not a function. Left 20 D3 fill color 1. So it goes forward length pixels, then turns left, and then turns left, and then it's ready to. Here it's ready to go. Here we are now going to draw the top right face of the octahedron. And D3 dot begin fill, D3 dot forward, self dot length divide by 2, 3 dot left. And don't ask me why I pick self dot left divide by 2 because I just because I feel like it and it looks cool. And I know it didn't show up anything because I didn't call this function yet. D3 dot forward self dot length times 1.4. I got these values out of trial and error as well. And D3 dot end fill and top X, top Y, D3 dot X core, D3 dot Y core. So that, and now we are at the top of the octahedron, the vertex at the top, and top left. So we have now finished the draw of the top right face. We now draw the top left face. D3 dot fill color 2. In fact, I'm going to move this here. I know it won't affect if anything, but it's just to make sure that it's organized. Infill D3 dot go to XY set heading 0 so that it faces east. 0 degrees is east, and then it just goes 1 degree counterclockwise from east, and negative is clockwise from east. And D3 dot go to XY so that it goes back to the original position. D3 dot set headed 0, headed forward self dot length, and then D3 dot go to top X, top Y, D3 dot go to XY, D3 dot end fill. So here we are. So here. So it would be nice if we can see what our current progress is right now. So D3 dot back 200, D3 dot down, D3 shape 3D 200 pyramid. No, not pyramid. Octahedron. Red, lime, blue, black. So let's see what our current progress is. So this happens because I failed to configure properly. So D3 dot set heading 0. So, and yes, that's our current progress, and it looks quite good. currently. So we are going to continue. Bottom left face. B3 dot. Actually, not yet. I forgot to explain why I talk about this. So I've set the fill color, and now we're going here forward. Then we're going to draw the triangle here, basically top left face. We fill it in, and as you can see here, go to XY forward, top, back. So that's why I said top left. And when I turn right 20 degrees, yes, fill cut so that you can see it here. Here forward, then turn left 110, and then forward half here, and then turn left forward the self.length times 1.4, and then end fill, and then this is all filled in. And now bottom left face, yes. D3 dot fill color 3, D3 dot begin fill, D3 dot set heading 0. Is that the heading is still 0 because I didn't command it to turn left or right yet. So that would just be a waste of time. And so I'm not going to do that. I'm going to forward self.length d3.left 20. And then no, actually I forgot some commands here. So d3.fill, it's not left 20, it's right 110. Sorry about that. d3.forward self.length times 11. No, not 11, 1.1 d3 dot end fill, and here we've had an extra space here, and then we're almost bottom x bottom y equals. So here we are going to record the coordinates again, and zero. So now it's just went back to its original place. Bottom right face, so that we have almost completed drawing the octahedron. Bottom right face is set forward length d3 dot left 20. Actually, this is part of so yes, now all of this was just configuration. So now at the bottom right face, d3 dot fill color 4, and begin fill d3 dot forward self dot length divided by 2, d3 dot go to bottom x bottom y, so that now it appears at a corner, and it just goes, and now that's the octahedron done, and there we go. So basically, what I said was it now goes to this point, and then it just goes here, returns here, and then we're done. And now we we have finished drawing two out of three shapes. Now the last shape that we're going to draw is the icosahedron. Define icosahedron. We drew the previous shapes that we drew were quite hard work, but I promise this is going to be the last shape that we're going to draw. So self color 1, color 2, color 3. So we have three colors, and 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 then we will go to record coordinates again. So hex chord equals trichord. It's also equal to that, and then 270. So that's our configuration for the heading hexagon drawing. B3.fill color 1, B3 begin fill. So we go to for I in range 6, B3.forward self.length times math. It does the paste still work? Oh, it does. So self.length times math.cosine 33.3 times divided by 180 times math.pi. Left 60 if I sent 2 is equals to 0. Nope, this is not the percent symbol. We don't want an astadan, we want a percent symbol so that it shows a modulo hex coordinate.append hex core dv.ycore. So that we record the important coordinates that we are going to use. d3.end fill. So what we have just done is we have finished drawing the 3D 200 icosahedron. We just go to so I forgot. Seriously? There we go. And so now we've just achieved a hexagon, but we are going to add the program now. So sorry, not program, details. So we need a triangle drawing. So we need to draw a central triangle. D3 fill color 3. Actually, I missed out the configuration. Right, 120. D3 back. 75. Don't, as I said before, don't ask me where I got that from because I got these by luck. So back, and now we are going to draw the central triangle. For I in range 3, do 3 dot right 150, do 3 forward, self.length. No, I'm not going to write that all again. I'm just going to copy and paste. Forward. There we go. D3 dot left 150. So that D3 dot forward self dot length. So currently we draw the triangle and we're also drawing some edges of the icosahedron. So this is what I'm currently doing. Try.append d3.y core. Actually, I've done this badly. No. There we go. And I'm actually going to move this to front so that we record the first bit, so that we've recorded the important coordinates that are required. And now we should have a thin. It should look like a cube with a triangle cut off. Now, and here we are going to connect this edge, this edge, this edge, this edge, this edge, and this edge, and fill all of these with green to make it look like an icosahedron. Although you might find that it might still look like a cube. In that case, you could just remove all the colors from the icosahedron, the faces. D3 dot up, D3 dot go to, try coor 0, D3 dot down, D3 dot fill color 2 for I in range 3, D3 dot begin fill. So here I'm trying to fill in the faces. So go to hex core I, go to try coor I plus 1, d3 dot end fill. So yes, it's because I forgot to add brackets. How did I forget that? This index out of range. Yes, that common error. Here, and I'm not going to put it there. I'm just going to put it there instead, and we just make it -1, and then we don't have to add an I at all anymore. And here we have an icosahedron. So we have finally completed drawing the icosahedron, and now all we have to do is to reinforce the borders of the central triangle for I range 3. With this will go to be easy. Try coor I and then finally we are going to configure these shapes so that they appear nicely next to each other. Back, down. I am not going to explain the configuration steps because they should be understandable without me explaining it. And then there's also d3 dot set heading 0, d3 up, d3 750, d3 dot left 90, dimension 3 dot forward 200, and here we could see the final. Um, what? Oh, mm, and here it doesn't matter where they are, but here we get to see uh, forward. So it doesn't matter where they are placed, but at least we get to see the final results of these shapes, and then this is the icosahedron complete. It might look like just a colored cube with a corner cut off, but to solve that problem, we can just remove all colors by saying white, 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 so that so that it doesn't look anything at all, and if you find that this looks better than the one that's been colored in, then you could just use this instead of a colored one, and and then I can safely say that it's the end of a video. Of it's probably Sorry about the fact that it was a long video, but do please subscribe, please like, because it took me so long to create these kind of colorful shapes. And goodbye.